Greetings, my name is Ryan Nix. I'm a solutions architect with Amazon Web Services. Joining me here today is Matt. Matt, say hi.
Hey Ryan, I am Matt Slaughton from Veeam Kasten. I'm a principal solution architect focused on our Kasten Kubernetes data protection product.
Right, for those of us who are not familiar with Veeam and not familiar with Kasten, would it be fair for me to say it is a backup DR recovery solution for most customers?
Yes, yeah, I think high level we like to call it data resiliency, but yes, backup DR is absolutely our core bread and butter.
I have a new looming challenge, use case if you will. We're seeing a lot of customers entertain moving out of their existing virtualization stack, and it's becoming very popular for customers to explore something like Red Hat OpenShift and OpenShift virtualization. So we're seeing traditional virtualization stacks moving into a virtualization operator running on top of Kubernetes. And one of the questions I have for you is, how, if at all, does this change my approach to disaster recovery resilience inside an OpenShift environment? Most of the customers I'm working with are using a product like Kasten for their app modernization workloads, so their containers and things. How does this evolve when we talk about virtualization? I think as a starting point, let's, for those who don't know, let's start from the ground up and have a look at OpenShift itself, some of those components. Most of the customers I'm working with are hybrid customers, so that they're starting in an on-premises context, and it might be helpful to reference what is on-premises and what is on AWS.
Absolutely, yeah, let's dive in. So yeah, I think high level you touched upon, OpenShift is becoming essentially one of the de facto platforms for containerized workloads. Right? So we're seeing a lot of containerized applications being deployed on OpenShift. A lot of these customers are using Kasten today to protect these containerized workloads, but now we also have OpenShift virtualization VMs entering the picture. So we need to make sure that obviously you can't have a more persistent data use case than VMs. So we need to make sure that we're protecting that data.
There's a bit of a misconception. A lot of customers think, app modernization workloads, containers and things, that everything is stateless. But unfortunately, there's always something in the broader organization that is going to end up being stateful. So having a look over here, you have Kasten running as a operator. It in itself becomes a containerized workload running on top of your container platform, in this case OpenShift. It in its own right is going to have some storage requirements and things that we'll talk about in a moment. The applications that my customers typically run are going to be container workloads. Some of those workloads are going to be talking to relational databases and things externally. Where there is a requirement for persistent storage on premises, it's typically some sort of SAN storage array, some sort of shared storage, in this case OpenShift Data Foundation being used. Is there anything in an on-premises context that's noteworthy here from a Kasten perspective that is going to have a ramification going forward in terms of the cloud journey?
For sure, yeah. So I think first and foremost, you brought the point up already, is that essentially Kasten departs a little bit from the traditional backup infrastructure approach, where traditionally we would say keep your backup off of your infrastructure you're protecting, but we treat Kubernetes as ephemeral. So we treat ourselves as an ephemeral application that can be restored in the event of a failure. So really important, I think one key difference and departure from maybe a traditional Veeam data platform approach is we actually deploy Kasten into the cluster. And that affords us a lot of opportunities that we wouldn't otherwise have.
So is that a byproduct of you're taking advantage of the resilience of something like Kubernetes, where if a worker node fails, it will move the Kasten platform, that sort of dependency?
Absolutely, yeah, and it affords us opportunities like being able to spin up replicas when we're performing backups, right? So we have these ephemeral pods that when we actually perform the backup, that's when we spin up our worker pods that perform the data movement, and when we're done, we can collapse and give those resources back to the cluster.
What's the next step here for most customers? In my case, it's a journey into AWS. It's taking their existing investments and they're bringing OpenShift into AWS. That could go in one of two directions. That could be a self-managed OCP, or it could be a managed OpenShift, Red Hat OpenShift services on AWS ROSA. Does that have any change in terms of Kasten deployment, Kasten versions, or is it irrelevant.
It's irrelevant. So that's the beautiful thing about Kasten and OpenShift, and in this case AWS, is that we can deploy using the same manner that we would on premises as we would in the public cloud.
Okay. So OpenShift is OpenShift is OpenShift.
Exactly.
Life carries on.
Yes.
In terms of application workloads, for most customers, the app is going to be some sort of, I think 3 use cases apply here. Some sort of app modernization workload where this is a container that the customer themselves has created and that application is going to run inside OpenShift. This could also be some sort of third-party solution that they've purchased that has now been containerized. I see this in some of the IBM spaces, has become very popular. In a virtualization context, this now becomes literally a virtual machine that the customer could have imported from something like a VMware as an example. Mm-hmm. I think in this context, let's treat these two applications as literally VMs. They're going to have definitions of the virtual machine itself, the metadata, and they're going to have the related storage of the VM, the operating system, everything that is that VM in itself. Mm-hmm. There's going to be potentially some information stored over here in the OpenShift Data Foundation, and there might be some related information in something else. This could literally be a hybrid use case where the customer is using something like Amazon S3 as an external entity. Mm-hmm. Let's go and pop that in over here. So this could actually be Amazon's S3 simple storage service, and we're taking some of that information there. Benefits over here is obviously this scales infinitely. You're not provisioning the storage outright. It is highly durable, it's highly resilient, and it becomes potentially a fantastic intermediary. But Kasten's also using this.
Yes, yeah, so very important news we like to say at Veeam and at Veeam Kasten is that essentially snapshots are not backup, right? So really important that we get that data off the cluster, because if we lose our cluster, if we treat the Kubernetes cluster as ephemeral, that's okay, but we need to make sure that we have our application and their data to recover.
You're protecting against catastrophic worst case scenario loss.
Yes.
The entire universe as we know it vanishes. Mm-hmm. I can still recover from that.
Absolutely, yep.
So Kasten over here, hooking into all of the components of OpenShift, of the application workloads, and moving that out into something like S3 as a recovery object. So it's basically all of the objects that Kasten can interact with.
Precisely, yeah. So and because Kasten is in the cluster, we can see the namespaces as they populate in real time in Kubernetes. So it's kind of a key differentiator for us is, let's say you've got a developer that's deploying a new application and deploys a new namespace, we can automatically detect that and protect that.
Okay, let's shift into AWS now. So same sort of thing. Most customers I work with tend to step away from doing things themselves. They want that undifferentiated heavy lifting. So when they come into AWS, they tend to gravitate towards a managed version of OpenShift. We've deployed Kasten over here already, as we would. What I commonly see is a change to the underlying storage infrastructure. We see a lot of customers change how they're going to take advantage of the AWS services. And AWS has a lot of options over here. Mm-hmm. We can take storage and attach it directly to the nodes of OpenShift and have directly attached storage. That's typically something like an EBS volume. We could get something that is going to give us a shared storage similar to OpenShift Data Foundation, and then again we've got a couple of options over there. Obviously all of this is running under the hood on top of Amazon's EC2 or our virtual nodes, but it's abstracted away because the customers are working through OpenShift in itself. What are you seeing as the most common storage option here in a virtualization context? So if you're looking at VMs running here, where are we getting the most bang for buck, and what are some of the considerations for a customer when they're looking at AWS services?
Absolutely, yeah. So one key thing which you touched upon well is the shared storage component, right? So for traditional container workloads, obviously there are some containerized workloads that need that read-write many, but there were ways that it could be architected where it wasn't necessarily required. But for VM workloads, if we want to be able to live migrate and actually move VMs from one worker node to another, we need that read-write many capability at our storage layer so we can actually move those VMs seamlessly, so we're not having to shut it down and then bring it up on another worker node.
So EBS really isn't going to cut it in that context. The problem with EBS is you don't have the read-write many. It is, if you're looking at Amazon's durability matrix, where we have availability zones, if your workload shifts from a compute node in one availability zone to a different one, you tend to leave the storage behind. So what I'm hearing here is it's a foregone conclusion. You're going to have something running on EBS as part of the OpenShift, so we do need to protect that, but our VMs are going to have some sort of shared storage. Let's quickly populate in a block over here. So we're going to see Elastic Block Store EBS. We're also going to see FSX and EFS as storage options over here. And personally, I think in a VM context, we're going to gravitate towards these.
Yep.
Now, we can use the solution to protect all of these. Is there any nuance, any sort of consideration over here?
So yes, there is a bit of nuance. So the good news and bad news of using something like EFS and FSX is we get read-write many, but we're essentially on a file system. So there is potential, in terms of capacity and performance penalty, especially for very demanding computational work or storage workloads, where we actually might see some degradation in performance. But for the most part, for VMs, standard workloads, these work perfectly well.
This is competition between the backup and recovery processes and the active workload.
Yep.
Okay.
Yep.
Some of that we can address through tailor-making the performance characteristics of the storage, increasing the I/O, those sort of things, and that's something we can absolutely do on AWS. It just needs to be a consideration. You need to have some sort of telemetry, things like CloudWatch, to see what's going on there, and then make a decision: do I need to do things at a different time, or do I need to change the configuration of my underlying storage to get that performance?
Absolutely.
From a virtualization standpoint, in a stereotypical VM context, I'd be backing up the VM and some sort of template definition and replaying that. I could get a fair bit of granularity here as well. What does recovery typically look like? How many different layers of recovery could I get in a virtualization stack here?
For sure. So, and it's a great question, because we can look at this from a DR perspective or a backup and recovery perspective, right? So obviously we can perform disaster recovery, as mentioned earlier, in the case of entire cluster goes away, but even accidental deletion, we can choose which components we want to restore. So in the case of a VM, we could do something like, we've got basic file level restore. It's coming in more of a substantial productized way in the next 6 months. But essentially, let's say I accidentally delete a file on my VM. I want to be able to quickly restore that. We can do that today by mounting a disk essentially back into our VM and performing that file copy.
So similar to like a utilization of a snapshot, I bring that snapshot, reinstantiate, and then pull the missing object back into my original storage. Cumbersome, but granular.
Yes.
So, fair enough.
Yep.
Stop people from deleting files might be a...
That's, step one, right. For sure,
Going into a larger blast radius, something like an infrastructure failure where we lose a disk subsystem, or we lose a underlying compute capability, so an actual... In this case, OpenShift is going to provide a layer of resilience. AWS is going to provide a layer of resilience. So it's less likely, but we still want to plan for that worst case scenario. So if the wheels fall off spectacularly and something unexpected happens, we do have the ability to recreate the volumes. Now, in this case, it's not just a volume, it's Kubernetes persistent storage. There's volume claims, there is the volume definition. So there's a lot of Kubernetes objects here, and I think what's happening is the operator is hooking into Kubernetes, pulling those definitions out, and backing those up as well.
Yes, exactly. So we pull the metadata and the underlying physical disk. So really important when it comes time to restore. In the case of a DR event, you're not having to go and do a storage restore and then go do your Kubernetes metadata or rerun your pipelines. You can essentially do it all in one go with Kasten.
Do DevOps personas, recovery admins have to manually stitch all of these things together, or does the product very neatly bulk everything for you?
So yeah, good question, and the answer is if you're not using Kasten, yes. So if you are trying to do a homegrown solution or maybe use an open source solution, you often have to stitch this all together. And we've seen some creative approaches to doing this, but at the end of the day, we like to say if you're a Kubernetes or DevOps or DevSecOps platform engineer, you want to focus on keeping the lights on. You don't want to have to focus on messing with scripts and keeping those updated as you add workloads. So in short, yes, Kasten can essentially do that all in one go. And we say that's the difference essentially with Kasten is that when you restore, the application will actually come back online as opposed to maybe having a crash loop back off or something because something's missing in your metadata or your underlying storage.
People lose sight, and when I say people, my customers lose sight of there are many, many little peripheral things that are part of their architecture. Even looking at this architecture over here, you've got things such as advanced cluster security that is going to define the policies, procedures, and securities for my application workloads. I need to recover that if there is a failure. A lot of the information that relates to my workloads, that relates to security, is potentially going to be stored in some sort of key vault. In this case, it could be something like HashiCorp's vault. It could be something like Amazon's, key services. My image streams, my image repositories. I don't want to have to rebuild every image I've ever created in my life in the worst case scenario. So we do want to protect those. And all of these components are going to be factored in as part of my DR strategy. And you mentioned a very valid point there. Customers are looking to do what is going to grow the business. They're looking at what is going to get them best time to market, best value for customer. It's not investing resources and effort in terms of manually addressing and strategizing each of these. If I can get a product to do that for me, I can unleash my resources to do what's critical to the business.
Absolutely.
We've touched on a lot of things here, and I think for most customers this is a bit of a light bulb moment. Oh, I can now do virtualization on OpenShift and I can use the same backup and recovery technology for this and complement what I'm doing with virtualization stacks. What have we not touched on? What have we skipped over accidentally?
So just one thing I wanted to highlight, in terms of this architecture. So this is essentially built from our reference architecture we have on OpenShift and Kasten and on AWS. You'll see here we're actually starting to see a lot of customers implement this, where maybe on premises, that's where they run their day-to-day workloads, in their maybe their own data center or set of data centers, but they leverage ROSA as a DR target, right? So there's a good kind of hybrid approach here where in the event of a disaster, we can essentially kind of pre-seed all of that data. So by backing everything up into S3, we actually have what's called import policies that will actually import into ROSA. So the data is actually there, but the pods aren't running. Okay. But if disaster strikes, it's as easy as just spinning up the number of replicas or spinning up your
You've
VMs.
Just explained why we've got Advanced Cluster Manager at the top there, because now what we've got is the data's pre-staged. When something happens, if I want to move that workload across, I can use that overarching management layer coming from Advanced Cluster Manager to say, right, let's kick it over to ROSA being the active location, if you will.
Yeah.
This doesn't necessarily have to just be on-premises to AWS. I've got hybrid customers that run in a myriad of different locations. These could be building blocks as part of a much broader hybrid strategy, but that's a separate conversation that we'll come back to. Matt, thank you for joining me. It is fantastic having you here, and thank you for joining us.